The first problem on the practice test is which of the following lists of numbers is not a list of whole numbers. A whole number are going to be the numbers 0, 1, 2, 3, 4, so on and so on. They do not have a fractional part and they are not negative. So if we look at this, we could figure out which ones are not a list. 2, 5, 100, 10,000, and 100,000. Those are all integer numbers. They don't have a fractional part, and they're all 0 or greater, so that is a list of whole numbers. The next line, we have a square root in that, but the square root of 25, that's actually 5. So once again, they're all integers, all greater than 0. That would be a list of whole numbers. Looks like we have a fraction, but 10/5 is actually 2. So once again, they're all integers, and they're all 0 or greater. The next list down here has a fraction, which is not a whole number, and it has the number -2. So this is not a list of whole numbers. The next question says, which of the following represents a list of integers? An integer is going to be any number that doesn't have a fractional part. So it can go on forever from the negative side. It's whatever, then no -3, -2, -1, 0, 1, 2, 3, so on and so forth, and it's going to go on forever on the positive side. Okay, so let's look at the first one. Those are all integers there, but the square root of 3 is not an integer, so that would not be correct. In the next one, we have 6. This is not an integer here. This is 1.333. That's not an integer. That won't work. Let's look at the next line. A -2, 3, the square root of 4. Well, the square root of 4 is 2. 2 is an integer. 10 is an integer, and a -4 divided by 2, that's going to be equal to a -2. So C is definitely a list of integers. And let's just make sure D isn't one also. Well, look, here's 2/3. That's not an integer, so 2 has to be letter D. Okay, what's the main difference between the decimal portion of a rational number and the decimal portion of an irrational number? And let me pause this for a second. Okay, I paused it to shrink it down so we could see the whole question. And it says, what's the main difference between the decimal portion of a rational and an irrational number? Okay, so the main difference is, for a rational number, it can be expressed as a ratio of two numbers. So for example, the number 4/3, that would be equal to 1 1/3. So it is a ratio of two numbers, and the decimal portion of this is going to be 1.3333 repeating. So for a rational number, it can have a decimal that goes on forever, but it has to be a repeating decimal. Now for an irrational number, it cannot be expressed as the ratio of two numbers. It will have a decimal portion, but the decimal portion will never end. So, and it will never repeat either. So although it goes on forever, there will never be a repeating pattern. An example would be pi. That would be 3.1416, and I don't know what the other numbers are, but let's say 7, 8, 9, and I think that's, and then say, okay, this is pi. Well, somebody else can say, no, it's not. We can add some more digits out there. So 1, 3, 5, and no matter what you do, you can just keep going and going and going. There'll never be a repetition. You can't find its place on the number line, so that would be an example of an irrational number. So in summary, a rational number has a decimal portion that will repeat and go on forever, or it can end, where an irrational number will have a decimal portion that never ends and never repeats. What's the main difference between a positive integer and a non-negative integer? The number 0, that is not positive or negative. Okay, so a positive number will not include 0. The positive numbers, they don't include 0. But a non-negative number will include 0. So what we have to do is For example, a non-negative number, that's all the numbers that aren't negative, non-negative integer. So that would be, for example, 1, 2, but 0 is not negative or positive, so it would have to be included in the non-negatives. So non-negatives include 0. Which of the following is true for the number 0? The number 0 is not an integer. Yes, the number 0 is an integer. So this one is not true. So we can cross that off as being an answer. 0 is a positive integer. No, 0 is neither negative or positive. So it can't be considered to be positive. We'll cross that off. It is an integer, that is true, and it is not positive or negative. Well, this is a true statement. It isn't positive or negative. And the last one says it is a negative integer. Well, we already said it's not a negative or positive integer, so that wouldn't work. The answer is 5. Are real numbers part of the complex number system? Yes, they are. A real number is part of the complex number system. The complex number system is the overall number system, and it is composed of real numbers and imaginary numbers. And that's the complex number. So yes, it is a complex number. Okay, so the next one says order numbers. What you need to do to order numbers is you need to change them to all one type, either a fraction or a decimal, a percent, it doesn't really matter. The easiest way is just to change them all to a decimal. Then when I put them in order, I have to change them back to the original number. So I'm going to stop at the video here for a second and find the decimal equivalent of all these numbers, and then we can order them. Okay, I've changed all these numbers into their decimal equivalents. For example, a negative 5 halves, that's a negative 2 1/2. Negative 0.3, that stays the same, 3 is the same. A negative the square root of 9, well, that's a negative 3, and a negative 1/3 is a negative 0.333. So now we need to put these in order, and I'm just going to label them in order from negative to positive. So the most negative number would be the one that is a negative 3. That'd be my least number. Then I'd move on to a negative 2.5. Now then, I'm going to have a negative 3.3 or a negative 0.333. Well, this is a slightly larger negative number, so this in actual would be my third largest. And then we're going to now get into the number here. It's getting closer to 0, and then we go to the positive number. So when I order these, I'm going to put the original numbers in order. So my smallest number was a minus the square root of 9. Then I would move to the number a negative 5 halves. Then I would move to the number negative 1/3. Then I would move to the number a negative 0.3. And lastly, I would have the number 3. So when I actually put them in order, notice that I have the original numbers, not the conversion to the decimal numbers. And that's the end of this page. My battery's running low, so I'm going to stop the video right now.